Today we're looking at note 6-5, solve square root equations. So yes, we will be solving more square root equations today, but you will see how these will be different from the previous day. So if I ask you to solve this square root equation, just like before, the first thing I want you to do is isolate the radical. Okay, so in this case, that means I need to subtract 3 from both sides. So I would get square root of 5x minus 1 equals x minus 3. I can't combine x and minus 3 because one's an x and one's not. So I want to pause here for just a minute, okay? Yesterday we worked with square root graphs, solving square roots with straight lines, okay, because it was just a number. Now I have an x. I have an x in this line. So if I have an x in the line, it's no longer a straight line like this, horizontal. It's going to have some type of slope. So I want you to think about the possibilities for this. The possibilities for this are that yes, they can definitely not cross at all because my other line could be here and then those two things will never cross. Okay, the other possibility is that the line could hit it at just one direct point, or the last possibility is that the line could hit at 2 points. It could cut through it once and then cut through it twice. So if you've got an x on this side now, we're adding a whole different element. There could be now 2 solutions. So there could be none, there could be 1, and there could be 2 possible solutions. Okay, so now that I've isolated my radical, you're going to square both sides just like before. So, but again, the difference is when I square both sides on this 5x minus 1 is just that, but now I've got a FOIL. That x minus 3 squared means I've got 2 of those. So hopefully by now you've gotten good enough to the point to where you can kind of do this in your head. You're thinking, okay, I've got 2x minus 3s. That means x times x squared. Okay, negative 3x and a negative 3x here. When I've got the same thing squared, it's going to create the same thing on the inner and the outer of the FOIL. So that would add up to negative 6x. And then negative 3 times negative 3 is positive 9. So I hope that you'll get to the point that you can jump from this to this without writing this out at all. That you'll be able to do this pretty quickly. Okay, now your next step, here's how this differs from before. You're going to put in standard form, but more specifically, and I've spoken with you guys about this before, you specifically want a to be greater than 0, and that's in most cases. I've always told you before, having a negative a value is a pain to deal with. So it's easiest just to get a positive a value, meaning it's greater than 0, to work with that instead. So in order to have an a value that's positive, that means I'm going to move everything to the right instead of to the left, because if I move this to the left, that a value becomes a negative a value. So I'm going to subtract 5x and add 1. So subtract 5x and add 1 to both sides. So essentially that goes away. I have 0 equals x squared minus 11x plus 10. So now I'm going to see and ask myself, is this easily factorable? And yes, it is, because this is the same thing as x minus 1 times x minus 10. Because negative 1 times negative 10 is positive 10, and negative 1 plus negative 10 is negative 11. So then I know if I set each factor equal to 0, that x would equal 1 and x would equal 10. Those would be my 2 solutions. But when you get 2 solutions, a lot of the time, at least one of them is going to be extraneous. Not all the time, but some of the time. Okay? So we definitely want to go back and check. So before I box these answers, I'm going to check each of them. So I need to take my original problem, so going back to the top, 5, where I see x, I'm going to plug in 1, minus 1, plus 3 has got to equal x, so it's got to equal 1. And then doing this one, I would have square root of 5. Where I see x, I plug in 10 minus 1, then plus 3 equals 10. Okay, so let's solve each and see which one works. So this is going to give me 5 minus 1 plus 3 equals 1. So this is square root of 4 plus 3 equals 1. I can already tell you that's not going to work because that's 2 plus 3, and they're saying that equals 1. That's not true. Okay, that does not work. So 1 must be extraneous. That's an extraneous solution. Okay, let's try 10. So here we've got 50 minus 1 plus 3 equals 10. And yeah, that's going to work because that's square root of 49 plus 3 equals 10. That's 7 plus 3 equals 10, and that's true. Okay, so this is our true answer, but x equals 1 is an extraneous solution. Okay, so we'll box both, but we need to designate that x equals 1 as extraneous. Okay, so let us move on to another example. So we've got square root of 3x plus 6 equals x. So just like before, isolate the radical. So minus 6, we get square root of 3x equals x minus 6. Then we can square both sides. Okay, so you get 3x equals, when I fold that out, it's going to be x squared minus 12x plus 36. Okay, to get a positive a value, we're going to move the 3x to the other side. So I would get 0 equals x squared minus 15x plus 36. Again, you always want to check, is this factorable? That's the easiest way to solve because quadratic formula takes forever. So we want to try factoring first. So yes, x minus 3, x minus 12, that's what's going to work, those two numbers there. And then that means if I set each of these equal to 0 and solve, I would get x equals 3, and I'd get x equals 12. So you definitely want to check, okay? So let's go ahead and plug both of those back into the original. So the original was square root 3 times x plus 6 equals x. So that's for the first one, and then for the second one, square root of 3 times x, which is 12, plus 6 equals 12. Let's try both of these out. So this is square root of 9 plus 6 equals 3. So that's not going to work. 3 plus 6 equals 3. That's not true. Okay, so that's not going to work. That means x equals 3 is extraneous. Okay, and then let's try this one. So this is square root of 36 plus 6 equals 12. That's going to work because that's 6 plus 6 equals 12, and that's true. So we had two solutions. One of them ended up being extraneous. Okay, so last thing I want to talk to you about today is if you have a scenario where, let's look at this one, you have something like square root 3x plus 1 equals square root x plus 17, say. Okay, we've got square roots on either side, so there's really no isolating the square root because they're on both sides. So if that were to happen, what you want to do is you want to just go ahead and square both sides, because if you think about it, that's going to get rid of the radicals. So we have 3x plus 1 equals x plus 17, and then it becomes a nice algebra problem to solve. So subtract x, you get 2x plus 1 equals 17, and then minus 1, you get 2x equals 16, so x equals 8. All right, and then again, like always, you want to check it. We're going to box it. Leave a little bit of room just in case it's extraneous. We can write extraneous, but let's check it. So if I go back to the original, that would be square root 3, x is 8 plus 1, should equal square root of 8 plus 17. So 3 times 8 is 24, and 24 plus 1 is 25, so square root of 25 equals, And what do you know? 8 plus 17 is 25. So does the square root of 25 equal the square root of 25? Yeah, because 5 equals 5. So we're good to go. That's our solution.